Hello, everyone, and welcome to Virtual Planetarium Exploring Space, part of our MOS at Home programming. My name is Janine. My pronouns are she and her, and I'll be your moderator today. That means I'll be reading some of your questions and responses, which you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. If you'd like to see captions during today's program, you can click the Close Captions button at the bottom of your screen and select Show Subtitles. And if you're joining us on Facebook or YouTube, hello, we're so excited to have you here today. Unfortunately, I'm unable to see your comments at this time. We are so delighted to have all of you here today as our audience. Let's meet our educators for today's journey through space.
Hi, everybody. My name is Talia. I use she, her pronouns, and I am going to be your guide today, which means I'm going to be doing most of the talking, but I can't do this by myself. I need a pilot.
Hi, everyone. My name is Katie. My pronouns are she and her, and today I will be flying you through the solar system.
Yes, because today we are going to be talking about some of the little odd worlds that we have sent spacecraft to, and we're going to be doing this in honor of a very specific mission, which ended or completed its mission mandate just this weekend. You may have seen some of the headlines talking about the mission Hayabusa 2. Hayabusa 2 is a mission from the Japanese Space Agency. It launched 6 years ago, back in December of 2014, on a trip to an asteroid with the fun name, which I can always pronounce awkwardly, Ryugu. So the asteroid's name is Ryugu, and Hayabusa 2 arrived there in June of 2018, and its mission was to actually take a sample of the asteroid, to actually go down, touch the asteroid, take a sample of it, and bring that sample back to Earth. And it did this in 2019. It went down and it actually was able to touch down on the surface of the asteroid and grab some dirt. And it started making its way back to Earth about a year ago in November. And if you watched or saw any of the news articles from this weekend, the sample return capsule touched down in the Australian desert on Sunday. So this is a successful sample return. The container has been recovered. That little box that you see in this image contains pieces of an asteroid, which can now be studied in labs here on the Earth, which is a huge game changer. So this is a mission that just completed its mission mandate. The sample return capsule has come back to Earth. The spacecraft itself, Hayabusa 2, is still in space. It still has fuel, and it's still out there flying. So it may actually go visit another asteroid as long as it still has the fuel to get there. So in honor of this mission, I want to talk about a few sort of similar missions to odd little worlds in our solar system. So Katie, let's go into space. Now, the program we're using for today's presentation is called NASA Eyes, and it's available on the web. You just have to download an app and you can run it, and it's got sort of different focuses. We're using the solar system, Eyes on the Solar System version. There's also one on exoplanets, and there's also one on the Earth, and it's great for learning about the different ways we explore the solar system. And that's what we're talking about today. So for our first target, Katie, take us to the asteroid Bennu. So as Katie zooms in, you can see this is a little awkwardly shaped asteroid. It's not very big. And this asteroid actually currently has a spacecraft in orbit around it. And remember, these spacecraft names can be a little interesting. This spacecraft's name is Osiris-Rex, and its whole job is to study Bennu up close. So this is a spacecraft. It hasn't been in space as long as, and you can see it's actually still there. So because it's still in orbit around Bennu right now, this graphic has it still there. And what this spacecraft launched on September 8th 2016, which, for those of you keeping track at home, was also the 50th anniversary of Star Trek. And coincidence? I think not. It arrived so that was September 2016. This spacecraft took 2 years to get out to the asteroid belt and to enter orbit around Bennu. It's been there for just shy of 2 years. It got into orbit around the asteroid on New Year's Eve 2018. And this is another sample return. So this is another spacecraft whose job is to take pieces of the asteroid and get them back to Earth. Now, my question for you is, why do you think we keep doing this? There was the Hayabusa mission, which did that, and that was Hayabusa 2. There was a Hayabusa 1 that did something similar. And now we have Osiris-Rex, all of them trying to do the very difficult task of taking samples of asteroids and getting them back to Earth. Why do you think we want to do that so much? I want you to take a moment and think about it and put your answer in the Q&A. And if you think about it and you're like, I don't know, I have no idea, you can go ahead and put a question mark as well, because one of the most important things about science is admitting when you don't know something. So go ahead and think about why we might be so into the idea of getting pieces of asteroids back to Earth when we have a perfectly good spacecraft already out there.
So we do have some answers coming in. We have some question marks. Kaylin suggests that perhaps it's because we want to find differences. Noelle thinks that maybe we can learn about the past from space. We have questions about maybe there's rare earth minerals, or to know what asteroids are made of, or to see if life is there.
And these are all true one way or another. So the reason that we really want to get these samples back to Earth is because while we're on Earth, the labs we have on Earth are so light years beyond, pun not intended, light years beyond what we can do with any sort of lab work on the spacecraft. There's so much more we can learn from these samples if we can get them back to Earth and study them in an Earth lab. It's why missions that are called sample return missions are really what planetary scientists are most excited about. And we've got sample return missions, for instance, in the plans for Mars, because that would be a really big deal. But the reason we keep doing it for asteroids, so Hayabusa 1 took samples of an asteroid, Hayabusa 2 just got samples of the asteroid Ryugu back to Earth, and Osiris-Rex is going to get samples of Bennu back to Earth, are many of the reasons you guys listed. These asteroids are really pieces left over from the very earliest parts of the solar system, the very early history of our own solar system. And so that means if we want to learn about what the solar system was like in its early years, which we do, because what the solar system was like in its early years affected the way that Earth evolved. To learn about that, we have to look at pieces of the solar system that haven't changed a lot over the course of the last, 4 billion years or so. And asteroids are some of the closest places where we can do that. So there's a lot of other places in the solar system with very, very old, largely unchanged rocks, but the asteroid belt is one of the closest places for us to get to. We can get a spacecraft out there, you heard, in about 2 years. And so from that, we can learn what the asteroid is made of. We can learn what sort of minerals are abundant in the asteroid belt, because in theory, one day we might want to start mining asteroids for things that are hard to find on Earth. We want to see what the conditions were like in the early solar system that where these asteroids were formed. And we can learn more of all of that by doing sample return missions, by getting pieces of these asteroids back to Earth. So Osiris-Rex has been in orbit around Bennu, like I said, for coming up on 2 years, and it has taken its sample. So just in October, you may have seen headlines about this. It descended to the surface of Bennu and actually scooped up a bunch of material. Now, here's the funny part. It was supposed to actually do this 3 times with the idea of filling the sample container and then getting all that sample back to Earth. But Bennu is a bit of an odd duck, the asteroid. It turns out it's one of these asteroids that we call rubble piles, meaning it's actually probably not a solid chunk of rock. It's a whole bunch of tiny bits of rock that are held together by gravity. So when the sampler probe of the spacecraft hit the asteroid, it sunk in so deep that it actually filled the sample container in one go instead of needing 3. And when they pulled back, they realized there was so much asteroid in the sample container that they couldn't close the cover. It was actually a problem. There were pieces of so much asteroid in there that the cover couldn't come down. So they actually had to figure out a way to get that cover to seal. And they have stowed, it has been sealed. The sample is safe. They have stowed it. And Osiris-Rex is going to spend a few more months taking measurements of Bennu and observations of Bennu, but it's going to start its way back to Earth in March. And it takes about another 2 years for it to get back to Earth. So it's going to return to Earth. It's actually about 2.5 years. It's going to actually come back to Earth in September of 2023. So that's when it's going to do what Hayabusa did. It's going to send its sample return capsule back into the atmosphere to land on Earth. And we are going to have a huge sample of bits of rock from the asteroid Bennu to study in our labs, which is going to be very, very exciting. This was a way more successful sample taking than we were expecting. So that is the Osiris-Rex mission. That is a NASA mission ongoing as we speak around the asteroid Bennu to get us samples to come back to Earth. Now, before we move on to our next mission, Janine, are there any questions I should take the time to answer?
Yeah, we have a question about if samples have to be quarantined when they return to Earth.
They do have to be quarantined, and it's not because of anything that we're not really worried about anything from the asteroid contaminating Earth. That's not the worry. The worry is anything from Earth contaminating the asteroid sample. Because let's say we found a mineral in the asteroid. We want in our sample. We want to make sure that it came from the asteroid and not from Earth. And so this was actually a problem with the first Hayabusa mission. Its sample return container actually hit the ground really, really hard and partially cracked open. So there was definitely some Earth dust in there as well, which means it wasn't a perfect sample return. In a perfect sample return, nothing from Earth touches anything from the asteroid. The asteroid stuff is kept totally pure so that when you're studying it, you know what you're measuring and what you're learning about it is from the asteroid itself and not a little bit of Earth that snuck in. Are there any other questions or should we move on to the next?
I think we can move on.
Excellent. So there's one thing that Hayabusa and Osiris-Rex both had in common. They were both, well, there are a couple things. They're both sample return missions, and they were both studying asteroids. Both Ryugu and Bennu are asteroids, but asteroids are not the only weird small objects out in the solar system that we want to know more about. For instance, another one that we would like to know more about is comets. Now, comets are a bit different from asteroids in a couple of different ways. But we had a chance to really study one up close through 2016. And the name of this one is a doozy. You can see it on your screen now. It is 67P Churyumov-Gerasimenko. That is the name of the comet. 67P Churyumov-Gerasimenko. We in the planetarium at the Museum of Science like to call it Chuger for short. So Katie, let's go visit Chuger. Now right away you can see this thing looks different than Bennu did. It's First of all, like I said, it is not an asteroid. It is a comet, which accounts for its weird name. Comets are named based on when and who when they are discovered and who they are discovered by. So 67P would refer to, for instance, what that will tell you what time of the year it was discovered, stuff like that. And Churyumov and Gerasimenko are the names of the people who were credited with discovering it. Comets are usually named after the person who discovers them. And it looks different. You can see Bennu was one sort of lumpy object. This looks like two lobes. This one I've seen compared a lot to a duck, with the smaller lobe being the head of the duck and the larger lobe being the body. And we think that's because Chuger started out at one point as two objects, and they actually sort of stuck together. First by gravity, and now you can see they are attached to each other at the neck. So this weird looking object was visited by a spacecraft called Rosetta. Rosetta was a European Space Agency mission, and this one launched from Earth in 2004. So remember, I said it took about 2 years for Osiris-Rex to get out to the asteroid belt. It took Rosetta 10 years to make a long arc out to meet up with Sugar. It didn't get there until 2014. And then once it was there, it spent 2 years in orbit around the comet. And these were 2 very important years. Comets have a lot of ices on their surface and under their surface. And they spend part of their orbit way out far from the sun, where they're basically just cold and inert and not doing much. But as they get closer and closer to the sun's energy warms them up. Those ices start to turn to vapor, and that's when you get comets forming long tails, and that's when you get lots of these jets, which you can see in this picture of the comet. Those jets are gases from under the surface, were ice, but warmed up, turned to gas, and are now shooting out into space and shooting material off the comet out into space as well. So what Rosetta did is it stayed in orbit around the comet, and through its closest approach to the sun, through its most active period, and then at the beginning of its trip back out away from the sun when the comet started to calm down and become sort of quiet again. So we learned a lot about what was inside this comet because the comet was shooting it out into space. And we learned a lot about how this comet must have formed and how it behaves differently at different points in its orbit. So Rosetta actually ran out of fuel in September of 2016. And they decided to just go ahead and end the mission with what they call a hard landing. I'm pretty sure that's just a code name for a crash. So Rosetta is now, there is now a new Rosetta-shaped crater somewhere on this comet. A good memorial for the spacecraft that spent so many years studying it. And we're still actually learning new things about this comet. I should say also that Rosetta did actually land a little tiny spacecraft on the surface of Chuger. So this was the first time we had landed a spacecraft on a comet. The landing didn't go completely according to plan, unfortunately, but we did learn a lot from it anyway. So the Rosetta mission was a mission that I felt did not get enough attention when it was active. And hopefully now we can still continue to learn things about comets from the data that this spacecraft was able to take. So Janine, before we move on, are there any questions I ought to answer?
Yeah, Austin wants to know how big Chuger is.
Oh, do I know that off the top of my head? I think it's a, hold on, I'm gonna look this up for you right now because I should know this answer and I don't. I think it is a few hundred feet. Am I right? Oh, no, I'm wrong. It's a few kilometers. It's about 4 kilometers across, which is it's, I don't know, about 3 miles, give or take. Yeah, it's about 2.5 miles. So this comet is about 2.5 miles across, which is very, very small. It doesn't have very much gravity. That's actually one of the reasons when the lander tried to go in for a landing, it went awry. It's because this thing is so small, it doesn't have a lot of gravity. It made the landing very difficult.
That's pretty funny. We also have a question about whether these jets of gas, the tail of the comet, alters its orbit.
It can, yeah. It has to, not all at once, because these are pretty low pressure events, but over time it can, given enough time, it can alter the path of the comet. And this is something that doesn't just apply to comets either. The pressure from the sun can actually, over time, alter the path of asteroids as well, particularly ones that like comets get very close to the sun. So solar pressure is not a very strong force, but given enough time, it can have an effect.
Okay, I think we can go on to our next stop.
All right, because there's one more funny little object that I would like to talk about. And it's way, way, way out there. This one is not a comet. It's not an asteroid. It's a Kuiper Belt object, which means it's out way beyond the orbit of Pluto. And its name is Arrokoth. So way out here. This is the farthest object we have ever sent a spacecraft past, and it is another object that we think probably started out as 2 things and then were brought together by gravity and are now attached to each other. So Arrokoth is a Kuiper Belt object, which was visited by the New Horizons mission. New Horizons is a pretty cool spacecraft. It is the first spacecraft and only spacecraft that has ever seen Pluto up close. It flew by Pluto in July of 2015. And then it had to fly straight past Pluto. So it just kept going. And it just so happened that this object, which didn't have a name at the time, was more or less on the spacecraft's path. So they were able to give New Horizons a nudge and make it possible for it to fly past this object on New Year's Day 2019. So this is another realm of the solar system where you can go if you want to try and learn about the history of the solar system. In fact, this stuff's even more pristine than the stuff in the asteroid belt. We think of the asteroid belt as being fairly far from the sun, but the sun still affects the asteroids and changes the asteroids a lot more than these objects way out here. And there are a lot more asteroids in the belt. They encounter each other far more often than these objects out here, which are even more spread out. So something like Arrokoth is an even more pristine sample of the early solar system. It has changed even less than the asteroids in the asteroid belt. It takes a long time to get out here, though. New Horizons took 13 years to get out to Arrokoth, stopping by Pluto along the way, of course. And we had to go so fast by it that it had to fly straight by. There's no chance of doing a sample return from out here, which is why we can learn, it's easier to learn more from the asteroid belt. But this was a great chance for us to get a very extremely rare up close view of an object this far out in the solar system. Now, New Horizons had to fly straight by Arrokoth as well. And that means it's still going. This spacecraft still has fuel. It's still moving. So astronomers are looking for another object on its path, even farther out than Arrokoth, so that it can continue its mission and maybe fly past a new object. The trouble is, it's so far out that this is a realm of the solar system we don't know very well, which means we actually have to search and see if we can find a new target for it along its path, because we haven't found one yet. I love this little spacecraft. It's got a great story. So this mission is ongoing. Stay tuned. New Horizons is still out there flying, getting farther from home every day, and learning more and more about this completely weird part of the solar system. And that's all I have to say for today. Janine, are there any questions I can answer before we sign off?
I think we have time for one question from Danielle, which is, why is it so bumpy? So I think we could take that to all of the objects that we saw. Why are they so bumpy?
Yes, very few objects in space are smooth because even though there isn't a lot out here, they still get hit by micrometeorites a lot, little tiny things, and bigger things the size of your fist, things the size of a basketball, they're still flying around, and pretty much everything in space gets hit by these objects all the time. We don't really notice on Earth because we have an atmosphere to protect us. But little tiny worlds like Sugar, like Arrokoth, like Bennu, they don't have any atmosphere. They've got nothing to protect them, which means when something hits them, it leaves a hole. It leaves a little crater. The bigger the object or the faster it's moving, the bigger the crater. So a lot of these objects are very, very lumpy. And they're also, as we've said, oftentimes they form when multiple objects come together. In Bennu, it's a lot of loose objects, and they came together sort of to form one more or less central object. With Sugar and with Arrokoth, we think it was two larger objects that came together and stuck together, giving them that sort of two-lobed appearance. So there's a lot of ways that these things wind up looking lumpy. They tend to not be, nice, smooth, pretty surfaces, but they're so cool.
Yeah, and I think the things that make things look smooth on Earth are like things that are caused by atmosphere and liquid water and all this erosion and stuff. And there's none of that in space.
Nope.
Or at least not on these objects. All right, I think that's all we have time for today. So I'll let you guys say goodbye.
Bye, everybody. Thank you for your questions.
Bye, everyone.
All right, thank you guys. And thanks everyone for joining us today. We hope that you had fun, you learned something new, maybe about some new objects, or you came up with some new questions that you want to answer for yourself. You can be a scientist and do some research on the old internet. NASA is a great place to start. Lots of very good resources there. If you'd like to see other virtual programs we're offering, you can follow the museum on our social media channels, or you can check out www.mos.org/mosathome. If you enjoyed today's presentation and would like to support more programming like this, please visit engage.mos.org/welcome to support MOS at Home, and thank you to everyone who has. Today's program was produced using the free software NASA's EYES, which you can find at eyes.nasa.gov. Thank you everyone for participating, and we hope you'll join us again soon.